Hello everybody, this is Andy Pilc. It's day 40 of our astronomy unit. This is it, folks. This is the last lesson, the last video, total summation of everything that we've learned over the last 40 lessons in astronomy, space science. We'll start just by looking at a very current competition happening between SpaceX and Blue Origin. And after watching a couple review videos from this unit, you're going to jump right back into the question bank from yesterday. So in yesterday's lesson, I did cover the first 20 questions. So in this video, we'll take about 10 minutes to cover as many other questions as I can before it's time to go begin our summer. So here we go. We'll jump right into it. Question 21. The data shows the change in apparent direction of the swing of Foucault's pendulum at various latitudes on Earth in degrees per hour. If a Foucault pendulum were set up on Mars, it would most likely show similar changes in the pendulum's apparent direction of swing. Identify the motion of the planet Mars that would cause this change. So the only association you need to know with Foucault's pendulum is that as that very heavy pendulum on a very long string appears to change direction, it's spinning in this, or it's swinging in the same direction. It appears to change because of the planet's rotation underneath it. So on Earth, it would be Earth's rotation. On Mars, it would be Mars's rotation. Proof of rotation of a planet. 22. The photograph below shows a feature of the universe as seen through a telescope. The feature is best identified as. It's a little bit tricky to see, but we can see some of these spiral arms here, indicating that this is a spiral galaxy, much like the Milky Way galaxy that we are in. In fact, if this were the Milky Way galaxy, we would be right about here, somewhere in the middle of one of those arms or those spirals. Question 23. 14 billion years represents the approximate age of. This is always an opportunity that I would take to take a jab at the English teacher across the hall from me, but you don't know him. So we're just going to say that, the answer would be the universe. The universe is 14 billion years old. Solar system, Earth, those are about 4.6 billion years old, and the moon formed shortly after that. 24. Which planet has completed less than one orbit of the sun in the last 100 years? Well, the orbit period of revolution, we're going to be looking at the planet with the largest period of revolution, which would be Neptune. Here we go. 25. Compared to the size and density of Earth, the moon has, so let's take a look at it. Again, we have this information over here, but hopefully you do know that, where are we looking over here? The diameter and the density of the moon compared to Earth. Hopefully you know that the moon is much, much smaller than the Earth, but we also know here, based on this table, that the moon is also less dense than the Earth. So, smaller diameter, lower density for question 25, choice 1. Number 26, the diagram represents Earth's revolution around the sun. Points A, B, C, and D, represent Earth's positions in its orbit on the first day of each of the 4 seasons. The major axis and the foci of Earth's orbit are shown, that elliptical orbit. Since Earth has an elliptical orbit, the distance between the sun and Earth varies. Yes, that's true. And the other focus varies. No, that's not true. No, that's not true. No, that's not true. Best answer would be choice 1. Question 27. Looking at that characteristics of stars table from the ESRT. Let's take a look at what this question is asking us to do. The star Canopus has a surface temperature of 7,400 Kelvin and a luminosity relative to the sun of 1,413. Plot an X to plot the position of Canopus. So let's even see what type of star this is. So the temperature is going to be 7,400. So 7,000 is here. 7,400 is going to be closer to 800. So for surface temperature, I'll be pretty much here on my x-axis. And it's about 1,400 So this is a logarithmic scale. So if you've seen this before, this is counting up by 1,000. So it goes 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. So it's going to be pretty close to the 1,000 mark. Whoopsie. So right about here. So Canopus is probably a giant or a supergiant. So it's changing from its main sequence stage to the intermediate stage. But Canopus would be over here, and it asks for an X. So of course we will put an X. Let's take a look at the next question. Whoops, 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 whoops. All right, let's go on to question 28. Identified two stars in the graph that are in the same life cycle stage as the sun. Well, the sun is in the main sequence stage, so we could say Sirius, we could say Alpha Centauri, we can say Barnard star, or we could say Proxima Centauri, the closest star to us. 29. Describe one characteristic of the star Spica that causes it to have greater luminosity than Barnard star. So Spica, let's find it, is going to be over here, and we want to compare it to Barnard star over here. So one characteristic that would cause it to have a greater luminosity or make it higher on the table. So if the luminosity, check this out here, if the luminosity is increasing from Barnard star to Spica, one of the biggest differences between these stars is going to be the mass. So between those two stars, Spica would be more massive. That's the characteristic. I'm going to pause this because there's a fire truck outside my apartment. All right. Describe how the relative surface temperature and the relative luminosity of Aldebaran would change if it collapses and becomes a white dwarf like Procyon b. So Aldebaran is here, and what would happen for it to go here? Describe how the relative surface temperature and luminosity would change. Well, the surface temperature would be increasing, right, because it's going from about 3,500 to close to 7,000. And the luminosity would be decreasing from about 200 times as luminous as our sun to about 0.0004 times as luminous as the sun. So the surface temperature would increase, the luminosity would decrease. Let's continue. 31. Compared to the terrestrial planets, Jovian planets they are going to be larger and less dense. Best answer for that one. The Jovian planets are farther from the sun and more gassy. They're farther from the sun, so that would be wrong. They're less rocky. That's right. Best answer here would be choice 1. Question 32. Earth, the sun, and billions of stars are contained within the, and which one is it going to be? The fact that it's billions of stars would make me think that the Milky Way galaxy is the best answer. We are possibly in a constellation of a number of stars, but I wouldn't say that they're necessarily in the billions. The solar system only contains one star, which is our sun, and a giant cloud of gas is a nebula, which is what all stars start as, but eventually it'll turn into the star and its surrounding solar system. Timeline below represents time from the present to 20 billion years ago. A, B, C, and D are different times. Which letter on the timeline best represents the time when scientists estimate the Big Bang occurred? Well, we know that that was about 14,000 years ago, so the best answer would be D, right over here between 10 and 15, closer to 15 billion years ago. Continue to 34, probably have time for a couple more of these. Here we go. We see the evolution of stars, which table includes data that are characteristic of the surface temperature and luminosity of some white dwarf stars. Well, white dwarf stars, they're going to have a high surface temperature of about 10,000 Kelvin to 20,000 Kelvin, and a much lower luminosity, about 0.001 luminosity. So the best option here would have been choice 4, surface temperature of around 10,000 Kelvin, right? So right around here, luminosity of about 0.001. Choice 4 would be the next best answer for that. Another question on this evolution of stars diagram. Whoa, sorry about that. Which process generates the energy that is released by stars? We know that that's nuclear fusion. I'm not even going to go over that again, because you know I love those questions. 36, each diagram represents the moon's orbital position, and each table lists the time of high and low tides in meters at New York City for the dates shown. All right, so we have, looks like here, just taking a look at it, we have a neap tide, which is a weaker tide when the moon is at a 90-degree angle to the sun. And this would look like a spring tide when we would see higher high tides and lower low tides because of the gravitational attraction of the moon and the sun working together on the earth and the tides. In the diagram below, we didn't even need to use that. Shade the portion of the moon that is in darkness to observers on May 13th. So when looking at the sun, we would see the right side would be dark, the left side would be lit, and it would be half illuminated because it's in that last quarter phase. So I'm just going to draw half of it dark, and I'm going to make sure that I'm shading in the right side of the diagram. It's easy because the moon is on top. If the moon was underneath, then we would have to kind of flip the diagram around and it would be opposite. It's not the case here. Another way that you could have told is that since it's finishing up that cycle and going towards new moon, we would see the right side of the moon darkened because the moon always waxes and wanes from the right side to the left side. Tricky questions. 37. On the diagram below, place an X on the moon's orbit to represent the location of the moon on May 28th. So we have differences of about a week, right? So it's going to go 1 week from here to here. The next week, we can expect it to go from here to here. So we're going to put an X right there at that first quarter phase position. And again, right there to be specific. But of course, if it asks for the X, we're going to put an X. Let's go through two more. Which characteristic of the planets in our solar system increases as the distance from the sun increases? So again, we're going to be looking at this table, and the distance from the sun is increasing. So let's take a look. Is it the equatorial diameter? No, we know that because Jupiter is the biggest. The eccentricity of orbit, is that increasing over here? Well, over here it has a high eccentricity. Over here it's decreasing, so nope. Period of rotation, that's the planet spinning. Period of revolution, that's the planet's orbit around the sun. And it's also the law of harmonies, or Kepler's third law. So the best option would be the period of revolution increasing as we get further out from the sun. 39, according to astronomers, the age of the universe is 13.8 billion years, about 14 billion years. Let's do two more last ones. Let's do it. Light from distant galaxies most likely shows, well, we know that they are moving away from the observers. Those wavelengths are getting stretched out, making them shift to the red side, increasing wavelength, redshift. So redshift indicating that the universe is expanding. That's what our Big Bang theory states. And which graph best indicates the densities of the planets in our solar system? Well, we know that the terrestrial planets are going to be more dense than the Jovian planets. So just looking at this, I would imagine that it would be choice 2. But we can take a look just in case. So we have Earth at about, we're looking at densities here. So Earth about 5.5, Venus about 5.2. Let's take a look at Mercury. Again, also over 5, so that's good, good, good. Mars, 3.9, shown by the graph. Jupiter, a little over 1, 1.3. Saturn, less than 1. So it looks like the best option here would be choice 2. Okay, folks, that is all 41 questions. I hope you found this video useful and helpful. I hope you found all of these videos helpful, and I hope that you have some good stuff planned for the summer. Go out, be curious, learn about the world around you, and don't stop asking questions. That's it. Nice working with you. Have an enjoyable summer, and I'll see you folks next year.